So I'm going to cover how we know how to choose the statistical analysis for testing hypotheses. So you're going to, on the final exam, you're going to be given research scenarios and you're going to have to choose which analysis is appropriate. So there are some things that you might want to go into reading the research scenario and kind of looking for right away as things you want to look for. First, you're going to want to look at how many conditions there are. So how many conditions are being presented. Whether people are the same in all the conditions or different in each condition. So people are same in conditions or different. Whether we are looking at like what type of data. So the type of data measured. So in the dependent variable. So is it continuous data or is it just frequencies? Those types of things. So these are some things you want to look at. Whether variables are conditions or if they are variables that could be related. Variables are conditions or relatable variables. So, and it'll become more clear as we talk about it. So these are some questions you want to ask yourself right away. And we'll kind of go through and look at specifically what types of things you want to look at for each type of analysis. So moving forward, the FAM on determining which statistical analysis is appropriate. Thank you. Analysis or analyses that you want to kind of be able to distinguish between are the three different t-tests. The one sample t versus the related t versus the independent t. So with the one sample t-test, you're going to have, just like it says, one sample of data or statistics for the one sample. So either you're going to have the data for one sample or you're going to actually have statistics for one sample. You'll be comparing that to a given population mean. So it makes it kind of simple because you're provided a population mean and then you have one sample that you're going to compare that to. Okay? With a related t-test, you have basically looking at two conditions. Okay. Then the same dependent variable is measured in both conditions. So that is the key here in both conditions. So you have maybe before and after, but you're being measured on the same thing in both of those conditions. And the same people are in both conditions. So those are some key things you're looking for. So you have two conditions, two samples, but the same people are in those samples. And then the conditions are different, but the dependent variable that's being measured is the same in both of those conditions. Whereas an independent variable, there are two conditions. The same dependent variable is measured in both those conditions. So it's very similar in both conditions. It's very similar to the related t, but the difference is, and this is the key difference, is these are different people in each condition. People in each condition. So maybe you're looking at, as far as dependent variable, aggression, okay? You're looking at aggression levels in two different conditions. The condition might be gender. So the condition isn't necessarily manipulated, but you have males and you have females. Aggression is being measured in both of those, but the conditions are different, and there are different people in each of those conditions. So those are the key things that you can determine with the three different t-tests. Now, if you'll notice, all three of these t-tests, ultimately, we have two means. With a one sample, we're looking at the sample mean differing from the population mean. With the related t, we're really looking at the differences between the first condition and the second condition. This is actually 2, and that's 1, which equals the d. So ultimately, we could have a mean for the first condition and the second condition. So there is 2 samples. And in the independent t-test, we actually have the sample mean of 1 and how it differs from the sample mean of 2. So these are ways that you can also determine. In addition, for this related t, if that seems confusing, ultimately we are looking at the mean difference minus the population mean difference, which is actually the mu, or the mu of the difference, which is the hypothesis that there will be no difference. So that is always 0. So if you want to think of it that way, that's a good way of looking at it, the numerator of the t-test. So all of these, that is very important, and this is the key. For all 3 of the t-tests, the dependent variable is continuous. So it's either interval data or ratio data, and that's all 3 of these. So that goes across all 3 of these, is the dependent variable is continuous. And with independent t-tests, same as ANOVA, but think 2. With any of the t-tests, think 2. The difference with the independent t is you have 2 conditions, different people in each of the conditions. The related t-test, 2 conditions, the same people in each of those conditions. And then the one sample t-test, you have 1 sample measured on a dependent variable that is being compared to a known population that is given. So these are the ways that you can go through and determine which analysis is appropriate. Hopefully this helps you on the analysis that you'll want to determine is our ANOVA. And specifically, we're only learning the one-way between subjects ANOVA. So ultimately, we have the same scenario as before, but we have 3 or more conditions is what, conditions instead of 2 conditions. So it's very similar to the t-test, except for now we have 3 or more conditions. This is why we would use the one-way ANOVA. We have the same dependent variable is measured in all 3 or more conditions, is measured in all conditions. So maybe I'm looking at, let's see, aggression levels in 3 age categories. So maybe I'm looking at pre-adolescent, post-adolescent, or pre-adolescent, adolescent, and post-adolescent. And I'm looking at aggression levels in all 3 of those conditions. So I'm going to be measuring aggression in every one of those conditions. So that's the dependent variable, and it'll be measured in all 3. And again, with the ANOVA that you're learning, there's going to be different people in each condition. So we're going to have, completely different people that are independent of one another. So, if you're looking at these pre-adolescent, adolescent, and post-adolescent, we're not looking at the same people at different times in their life. We're actually looking at maybe 5 people who are pre-adolescent age, 5 people who are adolescent age, and then 5 different people who are post-adolescent age. So they're different people in each of those conditions. And that's very specific for ANOVA, is 3 or more conditions, different people in each of those conditions, and the dependent variable is measured in all the conditions. One thing that I think I've missed for the ANOVA, that's another factor. Dependent variable is continuous data. So interval or ratio data for our one-way ANOVA. So these are some key things you really want to look for. The next one-way ANOVA, go backwards. We have 3 or more distinctly different conditions, and the same dependent variable is being measured in all those conditions. Different people are in each of the conditions, and that the conditions, the dependent variable, is continuous data, either interval or ratio. So think 3 conditions, 3 or more with ANOVA. Analysis is our Pearson R. So with the Pearson R, we don't have conditions. We have 2 variables measured for each person. Okay. And so these are basically, instead of necessarily dependent variables, they're what would be called a predictor outcome variables. So they're not conditions. So we're looking for variables that are related. Okay. So we have basically what looks kind of like 2 dependent variables. Then lastly is both variables are measured with continuous data. So we don't always say we're looking specifically for a relationship, but if we have the same person and they're not conditions, like a pre and post, or while doing something and while not doing something, and the dependent variable, both of these things are being measured with the exact same thing, if the variables are two different things that are maybe looking at two characteristics or traits about that person that are being measured at the same time, it means that they're being looked at as a relationship. So that's a key aspect. Sometimes it looks difficult when you just look at the data, but you have to think about what does that data mean. So I might be looking at like age and response time. Those aren't two conditions. Those are things that, oh, we're looking to see if response time is related to age. So that's some key aspects for Pearson R. Is there's two variables for each person, and the variables are related, and both variables are measured with continuous data. So it might just look like there's two dependent variables, but there isn't. With ANOVA, it's the one, or with Pearson R, with Pearson R, are we looking at two different variables instead of two conditions? And could those variables be related? And are the data for both the variables measured with continuous data, either interval or ratio data? And then the next are our chi-square tests. We have two different types of chi-square tests. We have our test for independence, chi-square test for independence, and we have what's called goodness of fit. Okay, so the key way of determining which test is appropriate has a lot to do with what type of data and how many independent variables you have, or quasi-independent variables. So with a test for independence, you're going to have two independent variables or quasi-independent variables. So, or two quasi-independent variables. So basically, like if we're looking at personality type, type A versus type B, as well as gender, male or female. Now we have two independent variables. And secondly, those variables are measured in frequencies. So the number of women that have type A personality versus type B personality, the number of women who have, or the number of men who have type A personality versus type B personality. It's just frequencies. And the key is our variables or data is discrete. So our variables can be split up into categories that are either nominal or ordinal. So male versus female would be nominal data. It's just either you're male or female. Now, an example of ordinal data is maybe ranking in college status, like freshman versus sophomore versus junior versus senior. That could be ordinal. Those are two different variables, but both the variables are discrete variables. We're not measuring on any continuous data. Those are all the same for the goodness of fit, except for you only have one independent variable, one IV, or quasi-independent variable. So basically, maybe I just want to look at if there's a difference in the number of males versus females who are psychology students. So as you'll notice, they're all psychology students, but I'm going to look at and see, is there a difference in the number of males versus females who are psychology students? So it's just one independent variable. Or maybe I'm looking at What is animal preference? So how many of my students prefer dogs over cats or over birds? And see if there's a difference in the frequency or proportion. So again, that second aspect, measure is discrete categories with looking at frequencies. So it's really the same thing, frequencies or proportions. So these are clear ways. The key is with a goodness of fit is we're looking at one independent variable split up into several different categories, or we're looking for, with the test for independence chi-square, we have two independent variables with both of the independent variables split up into different categories. So maybe that dog versus cat scenario, with the goodness of fit, I would just say, I would ask the whole class, do you prefer dog or cat? And you have to choose one or the other. Raise your hand if you prefer dogs, and I count how many people prefer dogs. And then raise your hand how many prefer cats, and I count how many people prefer cats. That's a goodness of fit. But maybe for some reason, I believe that gender influences whether people prefer dogs or cats. So now I'm going to ask, okay, how many of you males prefer dogs versus cats? Okay, now how many of the males prefer, cats over dogs? And then how many females prefer dogs over cats, and how many prefer cats, et cetera, et cetera. So now I'm looking at two different things, gender related to animal preference. So those are the ways that you can distinguish between the two different types of chi-squares. So there's the summary of how we determine between the analyses. With chi-square tests, it's all about you have categorical data, discrete data, and whether you have one independent variable or two independent variables.